All right, so let's implement reverse on our singly linked list. The first thing I want to show you, just to make this a little easier, I added a method called print. This was not something you were expected to do, or I didn't even mention it until now, but it's just going to make it easier for us to see that our reverse worked, because it's kind of annoying when all that we have is the head or the tail to have to, iterate over it or check if we did it correctly, because for all we know, we might have swapped the head and the tail, but the inside might be totally wrong. So I made a method called print, and it's very, very simple. All that it does is it returns, or it actually doesn't return anything. It prints, it console.logs all the values in our linked list in order in an array. So why an array? It defeats the point of using a linked list to turn it into an array, but it's just the easiest way to print it in one line. I could have done a string, I guess, and concatenated everything, but this is just a super short thing. This is not about being efficient. It's just purely to help us see what's happening. So with my current list, here's the values in there. If I do list.print, it just gives me this array, and I can see the order that they're in. So when we do list.reverse and then print again, we want to see the opposite order so that we know it worked. Anyway, let's get started on reverse. So I'll add our reverse method in here. And the first thing that I'll do, remember we have three variables that we're going to try and keep track of. The current node, the next variable, the thing that's ahead of it, and the previous variable, the thing that's behind it that we're going to connect to. So I have to start somewhere. I'm going to make my node variable and start it at the head, this dot head. Then I'm going to swap the head and the tail. So this dot head now becomes this dot tail. This dot tail equals node. I can't just say this dot tail equals this dot head because this dot head is now changed. So I made it. This is just a shortcut. It's serving as a temporary variable, but we're also going to use this node variable in our loop. So what we need to do now is start our loop. And instead of a while loop, because I've been doing that in all of my solutions, I'm going to do a for loop just to show you that you can, because we're keeping track of the length. So I'll do for var I equals 0, I is less than this dot length, I plus plus. So now we have the bulk of our logic, where we're going to go through, and we've established that this is node to start. This is our very beginning. Now we're going to make a variable called next and set it equal to this node.next. And then we're also going to use a previous variable. However, at the beginning, previous is going to be null because there's nothing in front of it. So we'll start it at null, but we'll update it as we go. So let's do that now. I'm going to make a variable called previous, and that will be null. I need the variable keyword var, and I'll also do next, and we can set that to null, or we could just leave it like this. The reason we want previous definitely to be null is that we need to make sure that the end of our list, the tail, dot next is null. We don't want it to be undefined or something else. We want null because that's how currently the tail is set up. If there is no dot next, it's set to null. All right, so now what we do is we go through the list and we save the next variable. So we already have next. Next is going to be equal to whatever we're currently looking at, dot next. So that's what we showed here. If this is what we're currently looking at, we're going to take dot next and save it in our next variable so that we can move on to it in a little bit. Then what we're going to do is take whatever the previous value is and set this node dot next to be that previous value. So it starts at null. So the very first time, it's not very exciting. We're going to say node dot next equals previous. So equals null the very first time through, but that will change. Now all we do is we shift things over. We say, okay, so this was our current node. Well, now our current node is going to be whatever the next node was, and our previous node is going to be whatever the node used to be, what current used to be. So that's simple. At the end, we're just going to say previous now equals the current node, and the current node now equals the next node. We just move one thing over. And then that's actually it. Let's return this at the end. We'll verify that this works, of course. I know it can be conceptually confusing, so we'll try and step through it one at a time. But let's just make sure it works first. I'm going to run the code. And we look at our list, .print right now. Looks good. Let's do .reverse and print it again. And let's just make sure 100, 201, 250, 350, 999. It's totally reversed. Okay, so what actually happened here? If we look at the initial state, I'll put this in comments. If you understand this, I'm not going to teach anything new here, but if you want to walk through, I'm going to do that right now. So we started with this, and we have 3 variables that we're keeping track of. We have one that we're calling node. We have one that we're calling, here, I'm going to do it just like this. We have node, previous, and next. Previous starts at null, and next doesn't really start at anything. It doesn't matter because we assign it right at the beginning. So the very first time through, node is equal to this dot head right here. So now we're going to set next equal to node.next, which is 201. So this becomes next right here. Then we say node.next is actually previous, which is null. So in our new list that we're building, we have 100, and we're having it .next, we're having it point to null. So there's nothing there. Then we shift previous to now be 100. So this is previous. And then we set node to be what next was. So this is now node. And then we start the process over. Okay? So then we go next equals node.next. Well, here's node. So node.next gives us 250. Node.next is now reset to be previous. So that means 201.next is going to be 100, which is the current value of previous. So that's the same as us drawing this arrow right here. We're connecting 201.next to be the rest of the list. Then we update previous to be the node. So this becomes previous. Then we set node to be next. So 250 becomes our node, and we start over. Again, you can drop out of this video at any point, but if you'd like to stay in for the long haul, we go through again. Next equals node.next. So this becomes next, 350 does. Node.next equals previous. So now we're connecting 250.next is 201. So that's us drawing this arrow. We're building it backwards, one thing at a time. Now previous equals this node. I'm just going to get rid of next for a second and just shift these over. Previous equals node, node equals next. We go through again. Next equals node.next, so that's 999. Node.next equals previous, so 350.next is 250. 350 now points at 250. Previous equals node, so we shift all these over just like this. Perfect. Now we take next, which is going to be node.next, so it's next is over here, it's null. There is no .next. Node.next equals previous, so this node.next is now equal to 350. So that's our final connection, 999 points to that. Then this doesn't really matter because we're done, but previous equals node. So we shift these all over just like this. But we're now done and our loop has finished executing. It doesn't keep going because we used a for loop based off of the length. This loop runs 5 times, 1, 2, 3, 4, 5. If our list is 5 items long. And looks like we're done. What am I saying? We are done. It works. We can just double check one more time. Let's do list.print. And then we do list.reverse. List.print again. Opposite order. Let's look at the head. It should be set up correctly. And let's look at the tail. It should have null as its next. Okay, that was a tough one, I know. Or it's a tough one for me to explain at least. Hopefully you were able to understand what I was saying. Okay,